Welcome. Let's talk about making solutions and dilutions today. So you guys already have the tools you really need to know how to make a solution. So the key equation when it comes time to actually create a solution in lab is the molarity equation. So molarity is moles over liters, and you've used that before. And this is going to allow you to figure out how many grams of a solid you're going to need to mass out in order to make that solution. So for example, what mass of potassium iodide would I need in order to make 500 milliliters of a 0.2 molar solution? Just a quick note, as you already know, you do need to make sure you have liters in for the volume because the molarity equation is by definition moles over liters. But this is going to tell you how much of that solid you're actually going to need to weigh out in order to make the solution. When it comes time to actually make that solution, you're going to mass out that solid. You're going to quantitatively transfer it to its container. So whatever you're going to do that dilution in. Oftentimes a volumetric flask. Sometimes when we can be down and dirty, we can use a graduated cylinder. But we're going to make sure you're adding solvent to dissolve it. For our class, we're going to be using almost exclusively water as that solvent. Quick note, if you're doing a down and dirty dilution, you just want numbers that aren't super precise, so you're going to use a graduated cylinder to do your dilution in. Dissolve the solid first in a beaker. You cannot mix in a graduated cylinder. Volumetric flasks, though, you will be able to transfer the solid directly to that volumetric flask. And then you're going to add your solvent to the desired volume. And we'll talk about how to properly use a volumetric flask in order to get good results and actually have a known concentration of your solution to pretty good accuracy and precision. You're getting a lot of decimal places up using a volumetric flask. Making dilutions is something we haven't done as much up to this point, but the key equation for making a dilution is this one, M1V1 equals M2V2. Okay, so M1V1 is going to be your initial molarity and your initial volume. And then M2V2 is your final or target molarity and volume. A couple of things to note with this equation. First off, why does it work? Well, if you look at the molarity equation that we had used previously, molarity is moles over liters, you'll notice that molarity times the liters, so molarity times the volume, is equal to the number of moles. If you think about what's happening in a dilution, you start out with a small amount of a solution that's fairly concentrated. And then to this, you add water or solvent of choice, but we're going to use water. If all you've added is water, then that dilution doesn't change the number of particles of the solute that is in the solution. The moles stays the same. And so what we're doing with that M1V1 equals M2V2 equation is we're saying the moles I had at the beginning is equal to the moles I had at the end. What's different is the volume of solution that it's in. So we've gone from a more concentrated to a less concentrated solution when making a dilution. And we can use these dilution equations to figure out both how much of a initial concentrated solution I will need to dilute to get a particular concentration for my final solution, or I can figure out if I've done a dilution what my final concentration is, all using that same M1V1 equals M2V2 equation. So let's work this problem. What volume of 0.5 molar sodium chloride solution do you need to make 750 milliliters of a 0.2 molar solution? Notice with the dilution, you're always going from more concentrated to less concentrated. So let's plug our numbers in here. So my initial molarity is 0.5 molar. I don't know the initial volume. That's what I'm trying to figure out. But I know that my final molarity needs to be 0.2 molar. And my final volume is going to be 750 milliliters. I can solve this for my volume, and I'm going to find that I need to dilute 300 milliliters of that initial solution. Something you might notice is a little different. I did use milliliters instead of liters for the volume. You can use either. Because the units on the left side and the right side of the equation are going to be the same, you can use either liters or milliliters and everything will be fine. Unlike the regular molarity equation that you have to use liters in. Here, you can pick. Okay, last thing I want to talk about is how you're actually going to make that dilution. We will practice this in class, and I will have all the glass for you so you can see what it looks like, and we'll talk through how to do it. But in brief, what you're going to do is you're going to measure out the volume of stock solution that you need. So you'll typically do this using a graduated cylinder if you don't need especially precise results, or you're going to use a pipette, either a volumetric pipette, which is the best, or a graduated pipette, which gives us a little more flexibility. Then you're going to take that solution and you're going to deliver it into a volumetric flask that has the desired volume that you need. You'll add solvent until you get just under your target volume, and you're going to mix well at that point. And then finally, you're going to add your solvent up to the line that indicates you have your desired volume. That mixing just prior to the final solvent addition ensures that any changes in the volume due to the chemicals mixing with one another do not affect your final target volume.